Hello, welcome to STEM School. In this video, we are going to go through Canadian computing competition problems. Let's take a look what we have here. So we got problem and quadrant selection. Okay. So problem description. So a common problem in mathematics is to determine which quadrant a given point lies in. There are 4 quadrants numbered from 1 to 4 as shown in the diagram below. So it's really basic mathematical problem, right? So we got quadrant 1 with 2 positive numbers, such as A here, with 12 and 5. Quadrant 2, we got the B point here, such as minus 12 and 5. So quadrant 3 here for C and quadrant 4 here for D. Okay. So pretty intuitive. So here's the description here from the problem description. So for example, the point A, which is at coordinate 12, 5 lies in quadrant 1 since both x and y values are positive, and point B lies in quadrant 2 since its x value is negative and its y value is positive. Okay, so that's for B, and your job is to take a point and determine the quadrant it is in. You can assume that neither of the two coordinates will be 0, so that makes easier. So neither of 0, that means nothing at the input won't be here, so it must be lying some of the quadrants, right? So here's the input specification. So the first line of input contains the integer x, which lies here. X is not equal to 0. The second line input contains the integer here. Y does not equal to 0. Output specification is the quadrant number for point x and y, right? So we got the input here, 12 and 5, and we got output here as quadrant 1. So again, x is 9, y is minus 13, the output is 2, right? So it's very easy. So I'm going to pause here for a few seconds and let you think of the solution by yourself first, and then we can take a quick look of what I've provided there. Okay, so here's the one. So let's take a look. So we got x equals the input, y equals the input, right? So if x is bigger than 0 and y is bigger than 0, that's quadrant 1. So else if x is smaller than 0 and y is bigger than 0, that's quadrant 2. And x is smaller than 0, y is smaller than 0, that's quadrant 3. And else if x is bigger than 0, y is smaller than 0, that's quadrant 4, right? So it's basic, very basic logics that we got from the problem description. So that's one thing. However, so my solution is just determine the very basic requirements that we need to do with this problem. But if we want to refine this solution, we can also think of the when there's the input, we can take a check of the input that it got from the x, and x must be lie within minus 1000 and 1000, and x can be 0. We can put the conditions determined there. So if x is outside of minus 0 and minus 1000 and 1000, or if x equals to 0, then we can ask user to re-input the x value, right? So that's something that we can refine our answer here, but here we already got a very basic logic, so that's just a hint for you to solve the problem above. Okay, so now let's take a look at our second one. So it's Shifty sum, problem number 2, Shifty sum. Okay, so the problem description, suppose we have a number like 12. Let's define shifting a number to mean adding a 0 at the end. Okay, that's shifting number. So for example, if we shift that number once, we get the number 120. If we shift the number again, we get the number 1200. Okay, So we can shift the number as many times as we want. So in this problem, you will be calculating shifty sum, which is sum of a number and the numbers we get by shifting. So specifically, you will be given the starting number n and the non-negative integer k. You must add together n and all the numbers you get from shifting the total of k times. Right, so that's pretty tricky. So, for example, the shifting sum when n is 12, so k is 1, so 12 plus 120, which is 132. The other example is shifting number n is 12, k is 3, so 12 plus 120, 1,200, and 12,000 altogether, right? So k is 3, so that 1, 2, 3, 3 times, right? So we shift 3 times and add together with the original number and get the sum, okay? So that's what we need to do. So input specifications, the first line input is the number n. So n has some limitations. It must be bigger or equal than 1 and then smaller or equal to 10,000. The second line input contains k, the number of times to shift n, right? So k must be between 0 and 5, okay? So the output specification is the output integer, which is shifty sum of n by k, right? So that's what we are talking about logics above. So that is the output. So here's the sample. So we got 12, we got 3, and that's the output number, right? So that's fairly, I would say the requirement, the logic itself is very intuitive, and I'm going to pause here again for a few seconds to let you think how you're gonna solve this by yourselves before we take a look at our final solution there. So okay, so now let's take a look at our solution. So again, we got the two inputs, right? So n and k. Again, we can refine our inputs, refine our answer by validating the inputs with the requirement input here. So n must be between 1 and 10,000. If it's out of this range, we can ask user to re-input. And the k must be between 0 and 5, and if it's out of the range, we can ask user to re-input. But now I'm just going to assume that we do the right thing, okay? So, but during the contest, if you really go to a contest, during the contest, you can think of all the possibilities, okay? So let's take a look how we can solve this problem from logic perspective. So we got total sum. Of course, you need to initialize the total sum and add the shift values, right, into the total sum. So we're going to take a loop, okay, from range 1 to k plus 1, right? Because why is that? Because we want to shift for k times, right? So the k usually is not included. Okay, so if we start from 1, we want to shift, for example, k equals 3, we want to shift 3 times. We have to 3 plus 1, 4 there, so that it will start from 1 and 2 and 3, right? So because 4 the number there is not included in the range, right? So then we got the total number and adding the n times 10, right? And then we just print the sum. Okay, so nothing very fancy, so it's quite intuitive. So the only thing we need to, the basic knowledge from Python, just the input, the for loop, and I don't think there's any specific things we need to use here. All right, so again, it's purely mathematics. We need to think of the range. We need to properly use the range, because if you don't put k plus 1, it's gonna just loop for what? For if k equals 3, it's gonna loop 1 with I equals 1, I equals 2, right? So it won't be 3, won't be included. So that need to take into the consideration. Otherwise, that's the whole logic how to solve this problem. That's everything for today's lesson. Please click like if you like this video and subscribe my channel. Thank you.